Alright, welcome to this module. Here we will be understanding what are the application of operational amplifier. In last modules, if you have seen it, right, if you have gone through it, we have understood what are the characteristics of an operational amplifier, such as input bias current, right, what exactly input bias current means and how it is going to affect the operational amplifier, what are input offset voltages. We have understood what are slew rate, right, how you can measure the slew rate, and we have also seen that how we can measure using the equipment that we have. That is, we had a DC power supply, we had a function generator, and we have the oscilloscope. So, this is your function generator, this is your oscilloscope, and this is your DC power supply, right. We have took the help of a breadboard on which we have mounted the circuit, and we have seen what are the change in the signals when we apply some input signal, what is change in output signal, how we can measure the change in voltages, right, and how can calculate the IB. There were some formulas given in the table. So, those who have not attended that module, please go and see that module, and then you come to this particular lecture. Okay. Now, here today we will be understanding what exactly is an inverting amplifier, then we will look at what is a non-inverting amplifier, followed by voltage follower circuit, it is also called buffer, and finally we will have summing amplifier. So, these are the set of things in today's series. We will again divide into 2 or 3 different modules, so that it does not become too boring. The point is, whenever we look at something, we read at something, it is very hard to concentrate, and it is always good that you look at something for 15-20 minutes, take a break, and then start another module. That will keep your mind fresh, right. Also, whenever you work in a laboratory or when you study for half an hour, study for 1 hour, take 5 minutes break. That is how you should study. It will help to keep our concentration and keep our mind focused. So, we will start with the first experiment, that is the inverting amplifier. How can we use operational amplifier as an inverting amplifier? Now we already have discussed in the theory class that why operational amplifier comes or has been given a name operational, right. That means it can do several operation, right, that we have already seen. So, let us quickly see what exactly the inverting amplifier was, since it was already covered in the theory class. Then we will see how to perform the experiments, and we will move from there. Okay. So, if you look at the screen, today we are understanding the basic op amp circuits. These are all basic op amps. Okay. There are way complex op amp circuits. We start with the basic things. So, first is your inverting, then it is your non-inverting amplifier, then we have a voltage follower and summing amplifier. So, let us see first thing, which is the inverting amplifier. Right. Now, this if you recall, we have already seen in the theory class what exactly the inverting amplifier is, right. So, I am just quickly moving on this to the next slide after discussing this slide, so that we understand what was the theory class and we can correlate with the experimental class. Okay. So, if you see the inverting amplifier, we can see here that the input is given to the inverting terminal, the input is given to the inverting terminal, right, and non-inverting terminal is grounded, non-inverting terminal is grounded, right. So, if you assume there is a R1, this is a feedback resistor R2, and if you want to calculate or if you want to understand what was the equation of the output voltage, right, output voltage, then we can see here, right, that if you apply voltage at the inverting terminal, you can see that I, the current at this particular point, I1 would be V1 by R1, right. Here it would be I2 equals to I1 V1 by R1, since the difference is 0. The VO, if you really go on understanding how the equation comes into picture, you will find out that once you solve this, you can find VO equals to 0 minus V1 by R1 into R2. So, if you see this, finally you get VO equals to 0 has no meaning. So, minus V1 or minus R2 by R1 into V1. This was the formula for inverting amplifier, right. So, we have seen in the theory class. So, I am not going into detail how you have derived this particular formula, but Just to quickly recall, external components R1 and R2 form a closed loop, right, R2 and R1, this forms a closed loop. We have seen operation amplifier can be used as an open loop amplifiers, it can be used as a closed loop amplifier. So, this R1 R2 resistors help to get a feedback, and that is why it is a closed loop. Output is fed back to the inverting input terminal. You can see output is fed back to the inverting input terminal. Input signal is applied from inverting input terminal. We have already seen that input signal is applied to the inverting input terminal, right. So, always remember, when you talk about inverting amplifier, apply the input to inverting. Talking about non-inverting amplifier, apply input to non-inverting terminal. Now, input signal is applied for inverting terminal. Let us see configuration using ideal op amp, alright. So, the required condition to apply virtual short, we have also seen what exactly virtual ground is or virtual short is in the theory class. The negative feedback configuration, one is negative feedback configuration and infinite loop gain. These are the required condition to apply virtual short, we already know. Closed loop gain of this particular amplifier is nothing but minus R2 by R1, right. Differential gain will be V2 minus V1. What is V2? V2 minus V1, VO by A, right. Infinite input impedance, I1 equals to I2 equals to 0. Why? Input impedance is infinite, thus I1 will be equals to I2 equals to nothing but 0. 0 infinite input impedance means current cannot flow, that is why it is 0. This we are talking about inverting configuration using ideal operation amplifier, mind it here, ideal op amp. So, practical op amp, again input impedance would be not extremely high or not infinite, it will be extremely high, alright, not infinite. So, we are talking about inverting configuration using ideal op amp, 0 output impedance, right, this is also 0, but in reality if it is practical op amp it would be nothing but low, alright, not 0. Voltage gain is negative, right. You can see here, so negative of your R2 by R1 into V1. Input output signals are out of phase, this is very important. This we have already seen again in the theory class. What we have seen, that when we apply the input signal to the inverting amplifier, the output would be opposite phase. So, we apply a signal, right, we will see output which is opposite phase, this is 180 degree phase shift, alright. So, this is what is written, that input and output signals are out of phase, right. Next, closed loop gain depends entirely on passive components, right, independent of op amp. Why entirely passive components? You see, it depends on R2, it depends on R1, this does not depend on the operation amplifier. So, it completely relies on the passive components, alright. Next is closed loop amplifier trades gain, that is high open loop gain for accuracy, but finite gain for accurate closed loop gain. What does that mean? That when you talk about amplifier, there are two types of feedback we have seen, right. One is your negative feedback, another one is your positive feedback. Now, if I keep on going applying positive feedback, what was the thing that we have seen? If you keep on applying positive feedback, right, the amplifier will not really work as an amplifier, but it will be an oscillator, right, it will be an oscillator. To make the amplifier stable, to understand or adjust the signal, right, we need to apply a negative feedback to the circuit, then only we can change the gain, we can adjust the gain, or we can play with the gain, and becomes a inverting amplifier or non-inverting amplifier. Means that negative feedback will give us amplification, positive feedback will give us oscillation, right. So, we have seen both the things in the class. So, just to recall it. Now, if you see that we will have closed loop amplifier, so that is why we can have accuracy, for accuracy we will have finite but accurate closed loop gain, alright. So, these are the things we already know. So, just quickly look at your notes or look at the lecture notes and you will see. Anyway, now once we know this, which is our theory part, which we have kind of repeated, right, how can we actually take a operation amplifier, take these resistors, passive components, and how exactly we can place this circuit on the breadboard, and how we can check this circuit. That is the real thing that we need to learn today. And if you see in the next slide, you see here, this is the experiment, right. So, how to perform or how to calculate the gain of an inverting amplifier. Now, given that you have R1 equals to 1 kilo ohm, this one, right, feedback resistor RF equals to 10 kilo ohm, what will be the gain of this particular amplifier. So, first thing we have to understand what is the circuit. If you see closely, right, what exactly the circuit is? The circuit is that the input signal is given to inverting terminal, right. That means it is an inverting amplifier. Next, what we have to see next? Next is what is the value of R in, what is the value of RF. Now, we already know what is the value of what is the formula for V out. For inverting amplifier, V out is nothing but minus of feedback resistor RF divided by input resistance R in into input voltage V in, right. This is the formula, we know this formula, right. So, what we have to do first? First thing is connect the circuit as shown in figure. This is the figure, we will connect it, right. Next, apply 1 volt peak to peak sine wave at 1 kilohertz to V in. Here we have to apply a sine wave, right, peak to peak, right, which is 1 volt, right, 1 volt. So, let me just rub it down so it becomes easy to understand, right. What we are doing? Second point, this one, right, concentrate on this. What we have said? Apply sine wave, okay, 1 volt peak to peak is 1 volt, right. Frequency is 1 kilohertz, 1 kilohertz is a frequency, alright, nice. Now, what is the next one? Observe the output V out, you have to observe output and note down the peak to peak value in the table below. So, what is the given table? Given table is V in, V out, these two things are given, right. What is gain? Gain is nothing but V out by V in. So, this is V out, right, this is formula for V out. From there how can we find the gain? So, earlier when I was talking about V out is nothing but minus RF upon R in into V in. What is the gain? Gain is nothing but V out by V in. So, V out by V in will give us the gain, right. So, what is the gain? What is the actual gain, that is the experimental gain, and what is the theoretical gain? We can measure both the things, and let us do this experiment today. Another thing is repeat the experiment for higher and lower amplitudes and note down the observation. So, we will just change the amplitude of the signal, and we will see what is the change in the gain, alright. Calculate the gain observed in the table and compare it with the theoretical gain. So, there are several things that we have to do in this experiment. Let us start one by one. First thing is we will take a breadboard, and we will connect the circuit as shown in figure, right. So, for today I will request my another teaching assistant for this particular course, and he will be showing you how we can perform this experiment. I will tell you when he is performing the experiment, right. So, Suman Chatterjee is a teaching assistant. Suman, can you please come? So, if you see there, so that people can also look at you, yeah. So, he is Suman Chatterjee, and he will be performing the experiments today, alright. So, first we will start with the inverting amplifier. So, Suman, do we have the PCB breadboard ready? Okay, cool. So, can you please connect it? Inverting amplifier, this one, right. That means that if you again remember what was the circuit on our screen, it was that there is a op amp, there is one feedback resistor and one input resistor. Okay. Now, we can focus again on my hand, yes. So, we have a operation amplifier here, right, and then we have two resistors R in and RF connected in the same way shown in circuit. Then what is the next? We have to apply plus 15 minus 15 to operational amplifier, correct. This much is easy. Now, we will apply input signal to the inverting amplifier, non-inverting terminal, sorry about that. We will apply the input signal to the inverting terminal, and the non-inverting terminal would be grounded. Why? Because this is a inverting amplifier, alright. So, let us see how we can do it. So, I am placing it here, right. Now, we have here on this DC power supply plus 15 minus 15, right. Here we have plus 15 minus 15. So, we can first connect it here, and then we can apply the DC power supply. First we can connect and then you should apply. Alright. So, what he is right now performing is he is connecting the bias voltages plus 15 minus 15 to the inverting amplifier using op amp. Alright, and we already have grounded. Now, we can start the DC power supply, and you do not have to see this particular voltages, okay. Do not consider this. In the first module in the experimental section I have said that this particular power supply, it has plus 15 minus 15 here, red, black and green, right. From here we can get plus 15 minus 15, alright. So that plus 15 minus 15 is directly given to the operation amplifier circuit, and now we are applying the signal at the inverting input of the operation amplifier. What was the signal? So if you see the frequency generator, this one, you will see we are applying 1 kilohertz frequency, right. Let me just, yes. So if you see here we are applying 1 kilohertz frequency. What is the voltage? We have talked about peak to peak voltage, right. So you see what is the peak to peak voltage? Peak to peak voltage is 1 volts, right. You see that is a 1 volt. Now this signal we have to apply to the inverting terminal. So when you see that, you will see the probe which is holding in his hand. So you see this probe that he is holding here, look at this probe, right. So one is your signal and second is your ground, right. So he is applying signal and he will connect this ground, which is black one, to the ground of the circuit that is on the PC on the breadboard, alright. So please give signal to the inverting amplifier. So what he is right now trying is, he is giving a input signal, right, to the inverting terminal of an operation amplifier, alright. It is very easy, extremely simple experiment. That is why we have said these are basic op amp circuits, right. So we are now connecting the signal to the inverting terminal, or you can take another wire, longer wire. So it is easier, take this one. Okay, connect it, alright. So now he has given the input to the inverting terminal of the operation amplifier, right. Now we have to check the output, that is what is given in the screen. So if you see the screen once again, right, what was the table? Table is, we have a input voltage, we have the output voltage and we have a gain, correct. We have input voltage, we have output voltage, we have gain. That means we have given already this input signal, if you see in the table, right, to the inverting terminal, right. So we have seen in function generator what was the peak to peak voltage? Peak to peak voltage was 1 volt, right. What was frequency? Frequency was 1 kilohertz, correct. Now what we have to check? We have to check the output voltage, right, is not it. So we have to connect the oscilloscope with the operation amplifier circuit, so that we can see the output signal, alright. So that is what we are trying to do, of checking the output of the operation amplifier. So what he has done? He has just, it may look extremely complicated, but it is not complicated, okay guys. So we have just connected the frequency generator, which is here on my right side, right, and we have given the signal to the op amp, and we are just checking the output on the oscilloscope. Because of probes it looks complicated, it is very simple. One red wire from the frequency generator, that is the signal to the inverting, black to the ground, from the output one signal to the oscilloscope, ground connected to the ground. So it is extremely simple. Now if you really see that when we have applied the input signal, which is 1 volt peak to peak, right, 1 kilohertz, what is the output? That we have to see, right. So if you focus on oscilloscope, what we see here on the oscilloscope, can you please focus oscilloscope? Yeah, yes, peak to peak voltage. So what is the output? output is, see he is placing his finger so that we can see the output, right. So, this blue line is your output, the yellow line is your input signal. So, what we see, what you see? You see that the output is 180-degree phase shift to the input signal, is that it. So, when you see this yellow line and when you see the blue line, these are 180-degree out of phase, 180-degree out of phase, right. So, this is okay. So, what is the output voltage? Let us see what is the output voltage. Output voltage is 10 volts. What is the input voltage? Input voltage is 1 volt, right. That means that we have amplified the signal, right, and we got 10 volts at the output. Why we got 10 volts at the output? That is different case, we will see. Now, if you come back to the screen, so I know how much applied, I have applied voltage input signal 1 volt. What was the output signal? 10 volts, right. So, what is V out by V in? 10 by 1, that is 10, that is 10. So simple, so easy to understand, right. What is theoretical gain? Theoretical gain is same thing, 10 by 1, again it is 10. So, we see that not much difference happens when we calculate experimental gain with theoretical gain in this particular case. But what happens if we change the amplitude, right, that was the second case. So, you could see now, right, 180-degree phase shift, one thing. Second thing was that the output signal is higher compared to the input, that is the voltage at output is 10, voltage at input is 1, because RF by R in is nothing but 10 by 1, which is equals to 10. That means, it will amplify by 10 times the input signal. Input signal was 1 volt, output signal will become 10 volts, right. This is what we have seen. Okay. Now, let us see another one, that is we will apply higher or lower amplitudes and note down the observation. So, again if we can focus back on the frequency generator, what we are now trying to do, we have kept the frequency as it is and we are trying to change the input voltage, we are trying to change the input voltage. So, what is the input voltage now? Two volts, alright. So, we have applied 2 volts, alright. So, let us see when we apply 2 volts what happens. When we apply 2 volts instead of 1 volt, what is the output? What is the output? Let us see, alright. So, if you see in the oscilloscope, it is stripped, that is the reason that we want to apply 2 volts. Now, the first question that should come to your mind is, it amplified how many times? 2 into what is the gain? We found the gain was RF by Rin, right. So, 10 by 1 is 10, 10 is your gain. How much voltage you are applying? 2 volts, 2 into 10 will be 20 volts. So, we should see a signal which is 20 volts, signal is out of phase, that is correct, right, yellow and blue it is out of phase. But why it is now clipped here, why it is clipped, right, that is because the supply voltage or the bias voltage is plus minus 15 volts, right. So, we cannot see enough amplification of 20 volts at the output signal, alright. So, that is the reason. Now, if what happens if we decrease the input signal. Now, do not go with this that it does not look like 20 volts, it does not look like 15 volts, right, because we have adjusted the oscilloscope such that even this peak to peak is 15, that is a blue one is 15. If I put it here, right, the blue one is 15 and this one, so peak to peak is 20, alright, peak to peak is 20, but this is clipped, it is clipped here, and yellow one is peak to peak is 1 volt. That is why it does not represent that 20 volts is it looks bigger waveform or 1 volts is smaller, both look same, but we are adjusted in the oscilloscope so that you can see clearly, alright. So, do not get confused that the signal is not looking higher and it is not 20 volts, it is 20 volts. We can change it by changing the knob in the oscilloscope, that we have already discussed. Now, let us see if we apply a less voltage. So, again you can focus on the frequency generator, let us see. So, now we are applying 500 millivolts, alright. So, what happens if we apply 500 millivolts? let us see. So, now we apply 500 millivolts, it goes to your circuit, right, which is right over here, which is your breadboard. So, signal is connected to your breadboard, it is to your inverting amplifier, the output is connected back to the oscilloscope. So, from here to oscilloscope. So, now what we are looking at oscilloscope? We are looking at some change in the output voltage. What is the new value? You see again there is a phase shift, the output voltage now is from 1 volts, it is about 5 volts. See, peak to peak is 10, but the voltage that you can see at the output is nothing but 5 volts, all right. So, or you can say 520 millivolts. So, applying 500 millivolts at the input, sorry, 500 millivolts at the input, what is the output, that we have to see, right. So, what we have seen until now is that when you can change the input signal, and based on that you can easily see the change in the output signal. One thing that remains constant is the phase shift, right. You see yellow and blue, these are out of phase. So, we can always change the input signal, we can always amplify whatever we want, but we cannot amplify more than what we have given as a bias voltage, which is a plus minus 15. So, it is very easy, right. So, then if I put this value, I can calculate lot of things on my screen, which is the table, right. I can see V in, I can see V out, I can see V out by V in, I can see theoretical gain, I can change the amplitude, and I can see the change in signal. Very easy experiment, extremely basic experiment, but important to understand. Why important to understand? Because one thing that we understood in this particular experiment is that if we apply plus minus 15, right, what is the gain of the operation amplifier? What was that? If you remember, the gain of an operation amplifier was infinite. That means that if then the question comes that, okay, if the gain is infinite, then if I apply 1 volts at the input, then my output should be infinite voltages, right, is not it. So, that means that if I want to, so since I am right now in IISc, right, Indian Institute of Science, and I want to have power across whole IISc, right, I can use one op amp, one single op amp IC, and since its gain is infinite, that means applying 1 volt at the input, I can get infinite voltage, and whole IISc I can run, the power can be generated using one single operation amplifier. Is it correct? Because infinite gain. But what we saw, right, in experiment is that even there is infinite gain, right now we had a gain which is limited about 10, but we can always increase the gain. Even there is infinite gain, the output cannot reach to infinite value, but it is limited by the bias voltage. That means that one op amp cannot run the whole power or cannot generate that much power that whole institute requires, right. So, this you always remember, do not get confused that, oh, infinite gain means that we can have infinite voltage at the output. No, it depends on how much supply you have given to the operational amplifier, all right. That means that here the maximum we can go about 13.5 or close to 15. We will see that experiment also, that what is the range, of the operation amplifier that it can work on, alright. So, that does not mean that when we say infinite gain, that means that we have infinite output voltage, alright. So, this is very easy. So, like I said, we will break this experiment into few parts, so that you can take a break in between after every class. So, for now let us quickly recall what we have seen. We have seen an inverting amplifier, we applied the input at an inverting amplifier, we measure the output, from that output V out by V in, we have measured the gain, right, gain of the inverting amplifier, we have measured the theoretical gain of inverting amplifier, and we already know that V out equals to minus RF by R in into V in, that is the formula for your inverting amplifier. Then we have seen a breadboard, and we have connected the frequency generator, the signal to the input which is inverting input, so that the output is inverting, that is out of phase, 180-degree phase shift, which we can see on the oscilloscope, right. This is what we have done. Now, in the next module, let us see how non-inverting amplifier would work, alright. So, I will see you in next module. For now, let us take a break, alright. Thank you.